All right, today we are going to start with our warm-up. And we're just going to look at and write down anything that you notice and wonder. So take a minute to pause the video and look at these sets and write down anything you notice or wonder. So maybe we noticed some similar numbers. Those all have 4s. Maybe we noticed some 5s over there and 1s. There's a lot of different things we could have noticed. Some of them have parentheses, some don't. Maybe we wonder how they're related, and that's what we're going to kind of look at today for our notes. So if we look at example 1, we have the two sets of equations from our warm-up, set 1 and set 2, and they define the output. They're equivalent equations, so they're just written in different forms. So the expression that defines function h, this one here, is in vertex form. We can show that it's equivalent to the expression defining f by expanding the expression. Okay, so our general form for vertex form is f of x equals a parenthesis x minus h squared plus k. That is our vertex form, our general way to write that. So if we look at starting with h, this is our equation h, we can expand that, and the first thing that we could do is take this x plus 2 squared and write it as x plus 2 times x plus 2. And then we still have the minus 4 over here. Then what we do is take x times x to give us x squared, x times 2 to give us 2x, 2 times x to give us 2x, and 2 times 2 to give us 4. Then we have this minus 4 that we still have at the end there. Afterwards, we can go ahead and combine like terms. So x squared, this is the only x squared we have, so we bring that down. Then we have 2x and 2x that combine to give me 4x. And then we have plus 4 and minus 4 that cancel each other out. So that is how we end up with x squared plus 4x, which is the same as function f in set 1. So we're going to do the same thing for number 1 here and show that r is equivalent to p. So the first thing we're going to do is copy down equation r. So we have negative 1 times x minus 3 squared plus 4. The first thing we can do is take this x minus 3 squared and rewrite that. Remember, squared means we have whatever's being squared times itself. So we have x minus 3 times x minus 3. Then we can distribute. If you want to use the box method for this, you can. Or we can say we still have this negative 1 out front. We'll have to deal with that later. But we can take x times x. That gives us x squared. X times negative 3 gives us negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. That is where my parentheses close. And then we have the plus 4. Then we have this minus 1 hanging out in front. This is being multiplied to everything inside our parentheses here. So we need to now take this minus 1 and distribute it to all four terms inside our parentheses here. So negative 1 times x squared is negative x squared. Negative 1 times negative 3 is positive 3x. Then we have negative 1 times negative 3x again, giving us another positive 3x. And negative 1 times 9, which is negative 9. And we still have that plus 4. Now we can go ahead and combine our like terms. So we have these two x terms that can be combined and these two constants. So we have the negative x squared. 3x plus 3x gives me a plus 6x. And then negative 9 plus 4 gives me negative 5. So this is our equation, which you guys can see is the same thing as p. So this is p of x. Those equations are equivalent. The first one here is just written in vertex form. And because we expanded this, this is in standard form. Now if we look down here at our graphs, we have the graph of h and the graph of r. So if we look at our equation for h of x was x plus 2 squared minus 4, and r was negative 1 times x minus 3 squared plus 4. So if we look at these key points, remember these are written in vertex form. So we're looking at the vertex on our graph. So our vertex here is at negative 2, negative 4. So we see that negative 4 here in our equation at the end. However, our x value is the opposite sign. So we have a plus 2 in the equation, which means we have a minus 2 for our vertex. If we do the same thing and look at r of x, this is my vertex, and we are at 3, 4. So again, we have that y value comes from the end there, and our x value is the opposite sign from whatever's in the parentheses. So that's where we get our vertex in vertex form. The x value of the vertex is with the x, but we change the sign. And the y value is the number at the very end, and we keep that sign. Okay, go ahead and write down any questions if you have them at this point, and then we can go ahead and move to the next page. So we are going to look here. I've opened up a tab on Desmos. We're going to first graph y equals x squared. So if we go here, I can say y equals x squared. So here we have what we talked about before, our parent function of a quadratic, okay? And now we're going to add different numbers to x before it's squared. So for example, we're going to do x plus 4 squared or x minus 3 squared, and we're going to see what happens. So if we have y equals parenthesis x plus 4, then close the parenthesis and square it, we have that blue graph. Then we're going to do the other one, y equals parenthesis x minus 3, close parenthesis, squared. And now we have the green graph. So what is happening? If we look at our graph here, when we had plus 4 right here, when we had plus 4, it took our original vertex of 0, 0 and went to the left 4 units. So now this point is at negative 4, 0. Whereas with our green graph, we moved to the right. And now my vertex is at 3, 0. So that's where that opposite value comes from. If we have a plus 4 in the equation, we get negative 4 as the x value. We get the opposite. Same thing when we have x minus 3. We now get the positive 3 change. We are going 3 to the right in the positive direction. So we can go ahead and make some notes of that here. If we add to x, we move left. If we subtract to x, we move right. Okay, so it is the opposite. Typically, when we think adding, we think moving to the right, but it is the opposite here. If we add to x, we are moving to the left. If we subtract, we are moving to the right. So now we're going to look at some other things that we could do with our graph. So if we start with y, go to my highlighter. If we start with y equals x minus 1 squared, we are going to add different constant terms to the end and then multiply by some different numbers in the beginning and see what happens. So let me bring this back over. I'll go over here. So we are going to start, I'm going to remove those. And we are going to start with the x minus 1 squared. So we need our parentheses x minus 1 squared. If I add 5 to that, you can see we have now moved up 5 units. If I subtract 9, we have moved down 9 units. Okay, so that number is still going to be that vertical shift that we talked about. If we are adding, we move up. If we are subtracting, we go down. So let's go ahead and write that down. Adding, we move up. And subtracting, we move down. So same vertical shift that we had before. And then if we look at multiplying with some different coefficients, we are going to take, let's see, we have 3 and negative 2. So if I look at this graph, I'm going to get rid of that minus 9, and I'm going to put a 3 in front. So that made our graph more narrow, right? That's our vertical stretch, the same thing we saw before. And if I change that and make it a 2, still narrow, but if I make it a negative 2, now we're still narrow, but we have been reflected. Okay, so we still get that vertical stretch, we still get that reflection. Okay, so go ahead and write down whatever you need to for that. If you want to just write down that you could reference your page from yesterday, that's fine as well. But what we are looking at is if we have that negative sign there, our graph is going to open down. So if we look here at this table, we want to, without graphing, predict the coordinates of the vertex of the graphs of these quadratic functions, and then predict whether the graph opens up or down. Okay? We are going to skip the last row here, so don't worry about doing this very last row. If we look at this first equation here, we have y equals x plus 10 squared. So remember that this number in our parentheses gives us the x value of the vertex. So if we're thinking about our equation, our general form is y equals a times x minus h squared plus k. That's our general form for a vertex equation. And our coordinates are h, k. That's the coordinates of the vertex. Notice that the h is negative in our equation, but positive over here. So that's what we're going to decide from our equation. If here we have a plus 10, that means my vertex is going to be a negative 10 for the x value. It is the opposite sign. And then my k value is what gives me the y value of the vertex. Here I don't have anything that I'm adding. That's like a plus 0. So it's going to be negative 10, 0. And does this graph open up or down? We are going to look to see if at the beginning of the equation, do we have a negative, whether it just be a -1 or a -2, something like that. Any number that's negative, it will open down. This one doesn't have that, so this is going to open up. For our next equation, again, we take the opposite here for the x value. So that's going to be a positive 4. And then we take this as our y value, 8. We do not change the sign for the y value. And this one, we look at the beginning of our equation. There is no negative sign, so this also opens up. Our next one, we take the opposite of our number there. Because we have a -4, the vertex x value is 4. And we take this y value here, which is 8. So we still have 4, 8. It's the same vertex as the last one. But now we do have that negative sign out front. So that means this graph is going to open down. Our next equation, we only have x squared. There is nothing being added or subtracted like we had in the previous ones. So that means my x value is 0 because there's nothing there. We're not adding or subtracting. And then my y value at the end of the equation is -7. So our vertex is 0, -7. And we look at the beginning of our equation. There's no negative sign. So this opens up. For our next one, we look at our x value here. We have x plus 3, so that means the x value of my vertex is -3. And the y value is -5. We look at the beginning of our equation. We do have a number there, right? We have 1/2. But it's positive, so this is also going to open up. And our last one, we have x plus 100, so that means the x value of the vertex is a -100. And then we have plus 50, so the y value is 50. Then, if we look at the beginning of our equation, we do have a negative, so that means this graph opens down. Okay. Again, we're not going to do that last one, so you guys are good to stop here, but please write down any questions that you have at this time.